Alright, this is the last video in this playlist, 8.5. Now we're going to be adding, subtracting rational expressions that the denominators are not the same and they're polynomial so they're polynomial and they're unlike. Alright, so polynomial means more than one term. Alright, so for example, when you're doing something with unlike polynomial denominators, you have to factor the denominators completely. Okay? Oh well. So here, that's already factored completely because it's monomials. There's no factoring. Here, I can factor out a 3x squared. So when I do that, I get x plus 1. I have to cross that out, that way I won't get it confused. So let's rewrite it. 4 over 3x cubed plus x over 3x squared x plus 1. Alright. Now remember, when we're adding and subtracting, you must get the denominators to be the same. So what can I do that will make these the same? Well, they both already have a 3. This has an x cubed, but this has an x squared, so this one needs an x. This has an x plus 1, but this doesn't, so I need to give this one an x plus 1. So my common denominator, if I did it correctly, should be 3x cubed x plus 1. Alright? So again, this is 3x cubed, which already has that, but it's missing the x plus 1. So remember, so if I have to multiply this by x plus 1, I must multiply the top by x plus 1. So I get 4 times x plus 1, which will be 4x plus 4. Remember, you got to distribute. Plus, now what's the other one? Let me just refocus this. Alright. Now here, we're missing just an x. So therefore, I just got to multiply the top by an x. So x times x is x squared. I like to put that in standard form. Alright, so you got x squared plus 4x plus 4 all over 3x cubed x plus 1. Now, if there's anything nice about doing this, which even I don't like really doing this, is that the bottom's already factored for you. Alright, so when I'm showing you the methods for doing these with unlike polynomials, the denominator will always be factored completely already. So that means all you have to do now is factor the numerator completely and see if it cancels, and then you'll be done. So, what are the factors of 4? It's 1 and 4, 2 and 2. I want to add them, meaning these factors right here, that would give me 4. Well, it's going to be that. So that means it is factorable. This will be 2 and 2. This sign tells me I'm adding, so that means both signs have to be the same. And this is telling me that both signs are positive. Alright, if you notice here, none of these three are the same, so I can't cancel anything. And this is a monomial, so I can't cancel with anything else. So that means I am completely done. So there is your answer in simplified form. Right, so let's look at another example. I know you guys are all chomping at the bit here. Alright, what's nice about this one is, look at the denominators. They're not the same. They're polynomials because there's more than one term, but they are already completely factored. So we don't have to worry about doing any factoring. Alright? So, but I have to get the denominators to be the same. So in order to do that, I must multiply this side by x plus 3. And what I do to that, I do to the top. Over here, I need to multiply this by x minus 4. I do the same thing with the top. So my common denominator is x plus 3, x minus 4. Right? And look, it's already factored. I don't have to worry about that. So let's go ahead and multiply. So x times x plus 3, so that'll be x times x is x squared. X times 3 is 3x. Got minus, so this is a negative 6, so I like to put the negative there with it. So negative 6 times x is negative 6x. Negative 6 times negative 4 is positive 28. Combine like terms. So that gives me x squared minus 3x plus 28 all over x plus 3, x minus 4. So now, let's see if we can factor this. Factors of 28 are 1 and 28, 2 and 14. Let's see here, 4 and 7. I had a brain fart again. 4 and 7. I think that's it. Of these factors, if I add them, would give me 3. None of them. So therefore, it's not factorable. So I'm done. All right.
6 times 4 is 24. Did you write 28?
Oops. Negative 6 times negative 4 is positive
24.
24. Ah. All right, so that changes things. All right, so let's try it again. All right, factors of 24, 1 and 24, 2 and 12, 3 and 8, and let's see, what else? Is that it? 4? Yes, 4 and 6.
Alright, so it's still not factorable.
All right. Now we're adding them, but we want to get a 3. So that gives me 25. Nope. That's 4. Nope. Nope. And nope. So it's still not factorable. All right. So I should have just stuck with it and been all good. All right. So there we go. That is your answer on that one. Okay. All right. Last problem. All right. Again, denominators are not the same. They're more than one term, so the polynomial. But this one's already factored completely, which is nice, but this isn't. This is a difference of squares, which is x minus 3 and x plus 3. Right? But you notice both of these denominators have an x minus 3, but this one has an x plus 3, so therefore I must give this one an x plus 3. And remember, whatever you do to the bottom, you do to the top. So my common denominator is this. Okay? Look, it's already factored, so that's nice. Now we'll go ahead. We didn't have to do anything to this term, which is nice, so we just keep it. Plus, you've got to take this 4 and multiply it through. So 4 times x and 4 times 3. Combine like terms, so that's 10x plus 13 all over x minus 3, x plus 3. All right, so we added those two fractions. Now we have to simplify. In order to do that, you have to factor completely, but the top is not factorable, so therefore we are done. And there you go. All right, so that finishes the series on adding and subtracting rational expressions.